to place the bicycle cable again on there, and we're using some 3D printed brackets, but it's not like, it's fine, we can still use them. So we'll have them installed tomorrow. But yeah, I'll post some nice videos and photos tomorrow to show you guys how the progress is. I've just been super busy with everything. Like I literally just got home like at 8:30 and I've been at it since 9 in the morning. So it's been rough.
Sounds like a good day.
Yeah, it's not as good when you're at it for like 2 weeks or something, no break. So, but I'm trying to get stuff done as soon as possible because, oh, also Reach RS is giving us some troubles. We had ordered it, but it's nowhere to be found all over the USA. Like no one has it. We ordered it from England and they don't have it. So they're supposed to send it over to us early May. So.
Do you want something better? I've got a Pixie Multi that you could use.
I mean, we can definitely use that if you're offering it, but we've ordered it, so yeah, we can use it if that could definitely be a backup or something if nothing comes out.
In fact, I've got another one I might you might want to use.
Oh.
Yeah. So
that's amazing.
Let me know if you're ready for it and you want something and you don't have it. I'll get you set up.
Yes, I'll definitely ask. Yeah. Thank you so much. Yeah, that's some pressure off my head, honestly, because I've been running around trying to chase that purchase order, and because we've been communicating with Russia, Assembly based in Russia, so, and they've been really nice though. They're really fast at responding. It's amazing, even with the time difference and everything. And they're willing to send it out as soon as possible. So yeah. I found a nice package. Someone has written it, and they wrote it recently for this Emlet GPS Reach modules. And what it essentially does is, so each of these Emlet GPSs, they come with a Wi-Fi module inbuilt. So you just connect it over Wi-Fi, and you mention the port and the IP, and they have a node that can just get it through TCP, which is pretty cool. You don't need to connect a USB for that. It just does it over TCP, so less cables if you're concerned about them.
So I didn't catch part of that, but was that for the Reach?
Yes. So someone has made a Reach node. I'm trying to find the.
Well, I can tell you that Matt and Al and I have been experimenting with using my Reach, and we've been using the GPSD node, and it works really well.
Okay. No, I'm talking about. I'm mentioning this node because this uses this transfers data over TCP. So you don't need.
And GPSD does also.
Oh, okay. I didn't know that.
I've been clamping the GPS outside out on a pole, and then we just use it through the Wi-Fi.
Oh, nice. I didn't know that. Well, yeah, we found two different things that do the same thing. That's cool. Yeah, that's good to know. But yeah, I haven't. I'm trying to find transforms. I'm trying to find a way to transform the IMU data into the localization node. If anyone has had such.
That's what Matt and Al and I have been working on for the past 36 hours.
Wow. Matt, do you have any updates on that?
Yeah, you just have to define each one of those transforms. So I posted up there in the Slack channel where you can see the static transforms that are in the launch file. And then you just have to define the map ODOM base link to your base IMU link and your base link to your GPS. And I put all those transforms that are in our launch file up there in the Slack channel. Your mic is on mute.
My bad. Is it on MicroTrack?
Is it on what?
Is it on hashtag MicroTrack channel?
It's a reply to your minimum viable product.
Oh, okay. My bad. Okay, perfect. Oh. Yeah, I definitely need to go through this. Thanks for responding to it. I'm trying to find a pose, and then we'll see what I can do with that. But for now, yeah, over this week, our hope was to have the truck running by Friday, like manual control over Ackerman messages. It's been hectic, but I'm finally seeing it come together. I have some. Yeah, I'll have some videos tomorrow for sure to show you guys all the stuff that's been going on. I just haven't had time to, yeah, and I didn't come here last week, so there's been a lot on my plate I've been trying to get to.
Sounds like you're making good progress. That's cool.
It's some progress. We'll see how good it is.
We also created a package for that robot localization that's using GPS and IMU with the parameters and the launch files up there on the GitHub site for Ross Agriculture.
Oh, that's great.
So if you want to check your settings, compare.
Yeah, that's definitely something I'm looking at these days when I'm not working on hardware. That's great progress, though. Yeah, it's been crazy, but yeah, I think that's all from my side. I think we're trying to get the hardware running and software. Software I haven't touched much, but I'm trying to get to it soon. But yeah, I'll definitely look through your files, and it would be great to use something that you already figured out.
1 month of data, 1 month of time left.
Exactly.
I've got a little RViz graph showing the robot localization filtered versus the GPS data.
Oh.
I'm not sure if it's correct or accurate, but this is the first go at it.
Are you using your Razor?
Yes, so this is with the Razor IMU and then a little $35 GPS.
Mm-hmm.
And I don't have any and this isn't plot, so I'm trying to plot this out on RViz satellite, but it's not lining up correctly. I'm not sure why. So the red dots are the raw GPS data, and then the blue line is the filter through robot localization. So still some more work to do and to try to understand how it's making these, and if I have it set up correctly.
Matt, you're showing the participant list that's blocking most of the screen.
Fantastic, I'm glad. How about this one? Is that better, or is it still participant list?
Still waiting for it to come through.
Okay.
I've seen a blank screen.
All right. Well, maybe I'll make a recording and then upload the recording. Maybe that'll be a little bit easier.
Matt, what is that? Are you showing the trajectory of a vehicle?
Yeah, I'm actually driving around in a vehicle.
Is that a real vehicle or is it a simulator? Sorry.
No, yeah. So this is real data.
Oh, cool.
From a GPS and an IMU. I just put it in my car and drove around. So I don't have the transforms correct. I'm in my car. I'm just kind of taking data, so that may affect coming around those corners. So I need to get the distances right, mount that in my car, and then try it again.
And you've logged the data and then post-processing that to show it an RViz graph? Is what?
Yeah, one of the nice features about ROS is its ability to collect raw data and then play it back. And so that's called a ROS bag.
ROS bag, yeah.
Yeah, you can just replay it, run tests against it, visualize it.
And that image is from like a Google map or something you're plotting on top of it?
Yes, so the package I was trying to work with is called rviz_satellite. And then it gets its map from an API called Mapbox.
I see.
It kind of works. I don't think I have it set up correctly. It is in the right location. It just my street, where I'm driving isn't lining up correct on the map.
I see.
Did you run the magnetic calibration on your IMU?
I used yours, Jeff.
Well, that's what you need to do is you put it on the vehicle and then run the calibration so it actually takes your vehicle into account. You want to put it, mount it down solid so it's not going to move, and then run your calibration. Basically, just drive around in circles until it says it's right, and then load those numbers in. The calibration, if you use the extended calibration, you download a, what's it called, a project processing. You download the processing code, and then they give you some code there. In fact, there might be an executable in there, so you don't have to download the processing. But you go out and you run that, and they want you to take it and rotate it around like this until you get a sphere. But if you're gonna have it mounted on a vehicle, you're just gonna drive in circles. You'll get just a circle that comes out of it, and then you just cut and paste those numbers and stick them into your code and recompile and load it in there.
Okay.
But if you don't do that, your magnetic's going to be off, and it's going to give you. It's going to be worse than if you didn't do that. So you might want to consider that.
Is that download from the SparkFun website?
I think it was on the ROS, the GitHub, where you got the original code. I think under there it says. Let's see if I can look quick here. I can't remember what it's called. Here. Well, I'll go look for it while you talk about whatever.
I think I found it. This is the laser IMU ROS to ROS page, like wiki page, ROS wiki page. If you can confirm that. Yep.
It is that Christoph robot thing. Now that I'm.
Yes.
So let me go.
Yes.
Find that one.
I just shared the link. If you can.
Well, except I want the
GitHub.
That's the SparkFun one, I think. I think that's, or is that the page on SparkFun?
No, that's from Christoph Robot. So.
Okay, let me pull that one up and look at it. That's, well, let's see, somewhere here it'll have the GitHub. Let me just type in what came in. It probably remembers. Christoph, GitHub. Copy that. How does this work? Like that? So there's the link to the GitHub that we can go look at. And under, there's a directory called magnetometer calibration. The one that says either MATLAB or processing. And let's see, under processing, I guess this doesn't have the compiled one. So there's under that directory is one called magnetometer calibration.pde, and that's what you run in processing. So you have to download the processing package. It's like the Arduino package, but it's more of a graphical type thing. So you start it up with that, and basically you say go, and then it starts drawing dots on the screen. You just move the thing around.
Okay, thank you. That would help. I'd like to test that with the Kyler's INS system. Just use that as ground truth and see how well.
Also, I noticed. Now I'm unmuted. I also noticed when you showed that thing on the plastic panel there. Keep in mind that GPS module has a magnet on the bottom of it, and you've got it next to your IMU, which is looking for magnetic fields. So you should either put a steel plate under it to keep the to capture the magnetic field, or just don't put the GPS anywhere near the IMU.
Okay.
So did you have this like laying on the hood of your car, or on the dashboard, or something?
On the dash. Yeah. And it was sliding around a little bit. It wasn't.
You want to secure it down so your IMU is good and solid, and once you get it secured, then run your calibration, and then hopefully if you can leave it there. I suppose if you say, why is this thing on the dashboard of your car? But say that's where it's supposed to be.
It works.
So about the placement, you said dashboard is the best place to put it. Yeah.
Well, I always thought you should keep it away from any metal at all, but it turns out on our tractor, we ended up bolting it right to the top of the transmission, which is the biggest piece of metal in the tractor. So we bolted it down solid, and then you drive the thing around in circles it gets rid of the extra magnetic fields, and somehow that works. So it doesn't really matter where you put it on the vehicle. I think you just want it so it's mounted and doesn't move around, and then
keep it away from changing magnetic fields, because Sohin has a generator, so that would not be a good place for it.
Yeah.
And the reason we put it on top of the transmission is because that's the least vibration we had in the machine. Everything else on there, like the ROPS up on top, the roll bar, and out on the hood and all that stuff, it vibrates like crazy when the thing's running. But in the middle, you got this big chunk of steel, and it hooked right onto the wheels, and that seemed to be the least vibration we had. So you can kind of, just when your vehicle's running, just take a look at it or put your hand on it and see if you can tell how much is vibrating in a certain spot. So generally, you don't want something that's going like this the whole time. If you can find a spot that's more stable, you'd be better off, I think.
The whole thing is going like this, honestly.
I've heard good reports from people using mouse pads for vibration dampening. I don't know if you can find a mouse pad anywhere.
You said a MOSFET?
A mouse pad.
Okay.
The neoprene kind of, or closed cell, I don't know, foam pads.
Yes, we do plan on having something like that. For now, we're not using the IMU as itself. Like I don't have it on board. Someone's making a 3D box for it, a 3D printed box for it. So yeah, that would be cool.
There's a couple of things also you can use. One is that I have used in the past is the mu metal. I'll post a link. I'm just trying to find out where I have it, but that's also a good shield. It's a really nice material that you can put. Also some rubber pads that you can use if you have a lot of vibration. The foam that also you can use is a good idea, especially if you have the barometer. What you wanted to do is you wanted to actually seal it with the foam. That's actually really a good idea if you're doing anything with it. So, I have the dampers, which I have used in the past for the quadcopters. Those are really nice, actually. You have those that you can put it on the standoffs, and you just really just significantly dampens the vibration. So it's if you have to actually build sort of a small like a rig for it, but once you have it, I think it's solid. So that might help. I'll post the link for the mu metal. It's really nice, good material. You can buy it off the Amazon, I guess, or eBay.
Is that MU metal?
It's called mu metal.
Okay.
Oh, it's magnetic shielding. Okay. But I doubt we can use a mu metal like all over. Like we can wrap this thing in mu metal because the IMU uses the Earth's magnetic field to.
No, it's for to separate it out. Like you want
just separate it out from the other parts. Okay, yeah, maybe yes.
Yeah,
definitely. Thanks for.
So is that like a shielding thing, or is it more vibration damper?
The dampener is probably for the vibration, but the mu metal that we're talking about is mostly it's kind of shielding.
Shielding. Okay. Okay. Got it.
Good to know.
That is cool. Good to know that. I mean, it's interesting for me to hear from you guys because I've forgotten long time ago how important sensor placement is on some of these structures to capture this. So it's fascinating to hear all those concerns.
That's one thing I need to find a place to place the sensor. I've got to do it yet.
Sam, you're on mute.
So these are some of the dampers that you guys have used when you use the quadcopters. But those are really nice too, and those goes with the M3 or M4. Obviously, everything's in quadcopters metric, but you can find similar 1/8 or quarter-inch. Standoffs, I would not use the metal ones if you can, and there are like good plastic ones, like bigger than this. This is like small things, but you can use it really effectively. Once you have that small rig, you can build it solid. You can put it somewhere with the mu metals, shield it whenever it's required to separate out your GPS or SIMUs. If you have any other sensors, good idea. Plus, you can also use the ferrite core that for the shielding too. That we usually use for the mostly for the like a aspects, something like this. So this is ferrite core. So that also helps. And then there are some other EMI shieldings too that probably helps. I mean, to reduce the interference as much as we could. In order to get the good data.
So what do you search for those vibration dampeners? What are they just simply called vibration dampeners, or are they? Yeah. You said they're for quadcopters, or?
Yeah. They were like mainly I've used that extensively for the quadcopters. I don't have one ready made right now. I don't see. But let me show you.
Okay, I found something that looks like what you had. I'll post a link to that.
Yeah. So I have the IMU and I have the barometer. So on this one, I have both, and I try and put it on a standoff. And what I do is, because this part is my barometer, and then I shield that with the foam, and I have this is my IMU, and put it. This is the BeagleBone black. You know, it's a cape that we build based on one project. So, and then over here we had a lot of interferences too, you know, and then we ended up putting the mu metal solid a little bit, and it worked really fine.
Sam, do you put that mu metal on the bottom?
Yeah, or if wherever you want it to separate it, you know, because you don't want any interference. Like GPU, if GPS with the compass, that's where you get a lot of interferences. You know, you wanted to keep that separate with the IMU data. I don't really take the sometimes GPS comes with the you know, the separate compass or something, that I don't take the data from that, and I take all those data from IMU. So I just want to make sure that my IMU over here, this is 9 degree of freedom IMU, and I wanted to make sure that that data is clean, so I get just the input from there.
Or you can buy a cheaper forge like Al has and Kyler. And don't have to worry about any of the magnetic interference. So a couple things that came up this week and last week in between. I met with Ross Industrial Organizer for the US, Matt, and one comment he made was to develop in the open. And so today we tried to upload the package for the tractor localization into the GitHub site. So it may not be correct, it may not follow the proper form, but kind of the idea is to push it out there into the community, and then we can all look at it, and then hopefully we can grow. We can make it work faster. One of the sayings we have at an incubator I went to last year is that if you want to go fast, you go alone, and if you want to go far, you go together. And so ROS can be difficult, and if we just build our own machine, we can probably make it through a little bit faster. But if we want to extend our machine and be able to accomplish larger goals, then it's better if we kind of move forward together and learn from each other. So if you start to see more packages going out on the GitHub site and they are terrible, then it's okay. We're still trying to learn how to make all this go together.
I think it's a great effort that you've made with the localization. That's exactly what I was looking at, and yeah, it's gonna save me a lot of time. So really appreciate all the work you guys did.
You bet.
Matt, you want me to talk about the performance?
Sure.
So I'm going to call this ode to Sam, since he was the cheerleader last. And, getting this done. Bear with me while I get screen sharing going here. So in the G drive, there's a installation guide. Step 7: connect the IMU and visualize the results. What that looks like, if I can get the file up, sort of hidden.
Can you guys see anything? I don't see anything on the screen.
The connection could be a little slow there where you're at, Al.
Sorry, say it again.
Sometimes your video gets frozen.
Bad internet connection here.
Can Kyler mute his video or his audio?
Oh, geez, I didn't realize it was on. Sorry. Thanks.
Well, is the quality any better?
Yeah, you can see the GitHub.
So there's a document out there on G drive around the IU and visualizing that, and it goes through connecting it with Tinkerforge provided software, getting it to the bottom line is we've gotten the Tinkerforge IM to echo data, and we've documented that in this particular installation guide. Creating a launch file to launch a Python borrowed from a package called Thumper, and ultimately to echo the output. That you're not going to be able to read that, it's probably too small, but trust me, that is the output. And then with Kyler and Matt getting that to visualize in RViz and the handful of instructions that you've got to go through in order to get that visualized in RViz. So that's really good, progress. Thanks again, Sam, for the motive. And we started another really rough, but another document to. Oh, this isn't the right one I wanted to pull up. There will be another document out there to take once you get the IMU connected and the data, to take the launch files that Matt mentioned and combine it with the GPS data. So I'm sure Matt can talk in more detail, but bottom line is if you're at that stage and you want to see it's done, at least one particular path to that will be documented and available to you. So that's where we're at. And then the step for me has been to start to write a listener publish target to be read by Pololu steering motor controller, the motor controller that's used for steering. To me, that's the next to get that talker and interfacing, raw a Pololu motor controller that's driving the steering motor. So inch by inch. Back to you, Matt.
Hey, I have a question. If you, so the Pololu motor controller that you need to write the listener for, how are you controlling that motor controller? Like, what are you planning to use to control that motor controller?
I'm going to let Kyler takes. I'm going to use whatever Kyler is kind enough to get.
Well, I think Kyler.
So can you be more specific? What are you going to use? Do you mean interface, nodes?
Yes. I mean, if it's an Arduino, we've already made that part, the listener part of it.
So the Pololu, whatever, has a USB interface to it. So there's, I think it does probably, it has an AVR programmable chip in it. So you can probably do some things on it, but we're just using the built-in firmware, the standard firmware, and using, when you plug into the USB, it comes up as 2 serial ports, and one's the programmer, and the other is for communicating with the microcontroller, and you can just send it commands. And so I think Al made some progress today on writing a node that will listen to a topic for steering commands and then send those on to the controller.
I see. I thought it was an Arduino base because we are using an Arduino and an H-bridge controller to control the motor for steering. So we went that route.
Okay. Yep. This is these JRK. They're basically servo units. So it's like taking any linear actuator with a potentiometer in it, for example, and you just put this in front of it, and it's a servo now.
Got it. Yeah. Thanks.
We did get an email from Ricardo at the ConstructSim, and he was wondering about joining the Ross Agriculture meeting on Tuesday the 24th, and then kind of review any of the questions that we had from the workshop, and then we could answer them live. So if that works for everybody, we can set that up as a meeting agenda for the 24th of April.
I mean, that's so nice of him.
Yeah. I do plan to join the transformation workshop. Thanks for sharing that link. This one. The transforms workshop that's happening tomorrow.
Have your questions ready.
Keep in mind on those videos that they are Central Eastern or Central European time, so you got to figure out like a 6 or 7 hour time difference on those to figure out. You can go on the internet and say I'm here and what's Central European time and figure out what the time difference is. I was thinking it was like the one that was, well, is that scheduled for the same time that our thing was on Saturday? Was that scheduled for 1800?
It is 1800.
Because that was like, for me, that was like 9 o'clock Saturday morning. And so it's, you got to figure out what, what that time difference is if you want to join the one live. Otherwise, as soon as it's done, it's just like ours worked, that as soon as it's done, you go to the YouTube video and you can watch it again. So if you don't want to watch it live. So as soon as he's done with it, you can watch it, go back and watch it on YouTube. That's all for me. Everybody seems to be waiting for me.
Hi, Newspan. Where are you from?
Everybody hear me?
Yes.
I'm in Nebraska, eastern Nebraska.
Great. Glad you could make it. Are you working on any automation projects?
Oh, I have no background in coding, so I'm way behind all of you guys, it seems. I did a little Arduino project, just controlling a stationary tractor throttle during harvest for an unloading auger. So I did a little bit with that, but I'm just exploring things. I have things I'd like to do, but I got a lot to learn.
You're in the right group. We all got a lot to learn. It takes time.
I'm curious how you did your throttle.
Oh, I used a 4-channel relay, like, I don't know, it was like a 400 megahertz something, to trigger inputs on an Arduino, and then I had linear actuators that had, you know, built-in potentiometers, so I could use set points for that. So I just had 4 different set points. I also had an actuator on the PTO lever, so I could manipulate the throttle and the PTO to a couple different set points from, you know, 30 or 40 feet away.
Sounds good. Auger control. I've got a friend here who did something similar. And in fact, he used an Arduino and relays. And then I introduced him to H-bridges. And that simplifies things a lot.
Okay, I've heard of that. I don't remember what that is. I'll look into that a little more. Good tip.
Take a look, and if you need any help, let us know.
Will do. Thanks.
Pictures of how you the interesting and useful, I think.
It was breaking up there a little bit, Al.
I said pictures of how connected the PT lever to the mechanical, you know, control would be interesting to see.
Oh, sure. Yeah, I could take something. This was a 55 series John Deere, so I just welded a little nut on the PTO control so I could just physically pull the lever up. It was nothing sophisticated, but I could probably take a few shots of it if people are interested.
Did you hear that, Matt? 55. Have you ever heard this?
I didn't hear you.
I said he's got he mentioned a 5055. It's the same model as my tractor.
Nice. Well, you guys are on the same development path. Look at that.
It was a 4455. Sorry if I didn't make that clear.
I'm sorry.
I'll make a comment since we're here. When you don't want to use the linear actuator, what do? Do you pull the pin and take it off?
Yes. Yep. That's what I did. It was just held on by one bolt and then a little quick remove pin because I never wanted to line myself up in case something went wrong. So I made sure they were quick and easy to disconnect.
Yep. Good call. I always used linear actuators, and I'm much more comfortable with them. But now I'm starting to see the value with servos, with like electric motor servos, the typical, like you would see for an RC car. And I've got some they'll move 80 pounds. So an advantage to those is that if you're not powering them, they don't get in the way much, so you can leave them connected. And so, and they have really easy control circuitry. You just send it a pulse train and it'll go where you want it to go. So you might think about using servos as a way to keep that manual control intact.
Yeah, I've never heard of a servo that large. That's interesting.
Oh yeah, they're out there, and they're 12 volt, which was important to me for mounting on tractors.
Yeah, yep, for ag applications, that's definitely advantageous.
Yep, that's what we use. We're using stepper motors for acceleration. I just posted a picture on Slack under projects. But yeah, that's our system that we're using. Not planning anymore. We're using it. But yeah.
So what size of stepper motors are those?
I don't know. They're big.
Yeah.
I have the model number somewhere, but I just don't have it on me right now. I can send those model numbers because that's what we use to figure out how many steps there are on it to map the acceleration output to the steps. Because the stepper motors, we have 2 stepper motors, so that, I mean, let me just share the screen so people on here who are not, okay, everyone can see. Can you see the, oops, can you see the picture?
Yep.
Yeah. So these are the 2 stepper motors and the controllers we're using, and this is a pressure cylinder that we're using for emergency brake. So as soon as we hit the emergency stop, this goes back in. We just haven't connected. This is an older picture. We have everything. We have most of the things connected right now, but this picture was taken last week. But yeah, we are using big stepper motors, and this whole pack, like this whole cuboid thing, this whole box, this will go slide under the driver's seat. There's some space under that there, so it's made exactly for that size. And we're running the bike cables that you can see over here through the transmission area and back to. We also have a bracket that holds the the other end of the bike cable. So, yeah, on the other side of the vehicle. And these bike cables attach to the brake and acceleration pedals.
So, sorry, Sohin, I didn't get that. The stepper, what do you use the steppers for?
For acceleration.
Okay. Okay.
For throttle.
And is there a cable that just wraps around the end of the stepper motor?
Yes. I don't have many pictures, but I will definitely send some pictures tomorrow when I get there. It will give you a better idea. So we have 3D printed a part that holds the cable, and it's crazy for now. We haven't run any tests on how sturdy we want the 3D printed part to be, but we have an option to just print it in metal. So, and we programmed both the steppers to go at the same time. So, and it's not going to be continuous acceleration. Our acceleration is from 0 to 3 miles. 3 miles or 5 miles is the limit. So we'll just map it to the steps we need on the stepper. And the bike cable is always in tension. So whenever we the stepper moves clockwise or counterclockwise to a certain step, that's how much acceleration we'll get out of it.
Very nice. It's a lot of work. You guys have made a lot of progress.
Definitely, it's some work, but hopefully it will be worth it. Oh, also this solves the problem of, this makes it possible to use it manually or autonomously. Like you just, it's always in tension, but when you're using it manually, it would just release some tension on the cable, and it wouldn't matter when you're using it autonomously. So this with this system, you don't need to take it off every time you want to go manual. That's something we thought of.
It's a nice option if you want to push on the brakes or drive it around.
Yeah, we're not using any. We're not using braking because the vehicle is so. It stops when you're moving at 3 miles an hour. If you release acceleration, it stops. So the only emergency systems that are on there is the braking. the pneumatic brake. So we have the system set so that once you press a button on it, we're using Zigbees for now. That's a recent update on the emergency. We're using Zigbee, so no one can tap into our 2.4, or it doesn't take any 2.4 gigahertz. Yeah, and we don't want it to just stop. So we're using Zigbees, and when you put in an interrupt, it's a separate system from ROS because we want it separate. So it's a hardwired system. It sends the Zigbee on that side a message, just an interrupt. So if the Zigbee on that side receives something, it would shut the engine and press this brake. So that works. And we also have a button on board. If you're on board, you can just press the button and it will cut the engine. And we have an Arduino that's reading all these messages. So like that's reading all these signals. So if an emergency stop has been made, I have the provision for the Arduino to send just a flag to the ROS system, so it knows that
what happened.
Yeah. So and then all the other code, like we will have a spray system back in the wherever it is. If so, it would be like if emergency equals no, then do this. So it would always stop when there's been an emergency or something. So that's how it connects to the ROS part. But other than that, it's completely separate. We don't have any brakes though. It's like acceleration 0 or acceleration 3.
Next year, add brakes.
Exactly. Next year. But yeah, just wanted to share the idea of not using the linear actuators, because we were pretty lean towards linear actuators, but it would just make things so much difficult putting on there. And this system is invisible practically. You can't see anything. I mean, it would all be underneath the covers and everything, so you won't be able to see what's happening, but it's just happening. And then we're using the EPS on the steering, so that's also hidden. So it's all like, it looks like a ghost is driving or something. That's pretty
nice.
Cool. Hoping to have it working soon. And that's all from my side, I think.
Thanks, Sohin. That's great progress. Great to hear. You think the first test drive will be next week?
Oh, yes, definitely.
Oh, wow. Fantastic.
Not autonomous, but definitely a manual test. That's something that I'm really pushing for this weekend.
Wow.
Because it's high time.
No. Is anyone stuck on a ROS package or a ROS problem? Maybe not just one, but a few. Is anyone learning any good things about ROS?
It's got a lot of things. So traversing through the packages, especially I'm focusing on the launch file at this point, and mostly the CMake and the package XML. So that's what I've been going through.
That's good. There's a lot. I have looked at them once or twice, but I try to stay away from them.
No, that's kind of necessary, yeah. And then I realized the easy thing is to build just a single node, but if you have more than one, where all the knowledge has to converge, and I see the launch file is the easiest one to actually start more than one node, including setting up the values, parameters, and everything else in between. So I think I see a lot of value in learning the launch file and all the syntax. So that's what I've been trying to go through.
One thing I noticed, I've been seeing packages that have the parameters set in the launch file and then others that have the parameters set in a YAML file. And I didn't know if the YAML file is sort of the new way, the proper way to do it now, and the other one are just old packages.
You can load the YAML file. That's what I've been learning with all the parameters. And people started doing that if you have lots of parameters.
Okay.
So that you can actually keep that YAML and at a separate place. So that's maintained and your launch file is not kind of too much crowded.
Okay.
Is there sort of a GUI in ROS to change the parameters of modules on the fly?
Yes.
There you go.
I ran across this recently. It was a required package for something I was doing. And it's an RViz plugin. Someone else jump in here. Matt, do you recall seeing that?
Sometimes we use the Dynamic Reconfigure.
Yep, that's it.
Dynamic Reconfigure. Okay. Cool.
I don't think that's a plugin to RViz, but it is something you start up and it will, if your program is written to accept that, it's really handy because you can change everything on the fly.
Looks like it's still a command prompt, right? CLI. Is there like a GUI for that, or am I missing something?
Once you start it up, it does provide you with a GUI and full, all the parameters are there. It lists them out and you can change them. You can get little sliders you can move back and forth.
I see. Gotcha. Thank you.
I just found a tutorial on the RViz Dynamic Reconfigure. I don't know if it's the right one, but you might want to look for it.
Yep.
It looks like a good package to use.
Another thing that I've been learning is Catkin make versus simple Catkin tools usage of it. I'm finding Catkin underscore tools. It's much more friendlier and kind of clean rather than building it through the Catkin make. So guys, take a look at it if you like that tool.
And that one was called Catkin Tools?
Yeah, Catkin underscore tools, and it's pretty simple Catkin build. It's very intuitive too. It makes a lot of sense, and I think it's just probably is recommended to build the packages with that. I mean, it's nice, it's clean. Just check it out.
When I was getting on with ROS, that there was something I found as well. Catkin build works better rather than Catkin make. I haven't gone into the Catkin underscore tools, the complete package, but I definitely use Catkin build, Catkin space build to build my packages whenever I want to.
Yeah, it's very easy, very simple. I'm just going to post the link. It's really nice. There's really a nice documentation out there. And it's very good.
The cameo by Kyler.
What did I
Yeah, hang on. I'm just going to find out the link if I could. It's very easy, simple to follow through, and I feel it's really more clean.
Okay, we'll take a look at those. Thanks for being here tonight. And we'll get Ricardo here on the 24th. He'll join us for our meeting. I think it's like 3 o'clock his time. So that's nice. He's getting up in the middle of the night to be able to answer any questions we have. And we will see you guys in the Slack channel and see you next week.
So guys.
All right. Thanks, man.
See ya.
Bye, all.